it. Getting jiggy with it.
Okay, so you have your composition notebooks, and we have our 4 colored pencils. These are the colors that I choose to be using to fill in my notes today. So again, we're going to open up our composition notebooks to the table of contents. We're on the 4th page. We're going to go ahead and write greatest common factor, or GCF, and then least common multiple, or LCM. And again, we'll go to page 4. And I have the notes already given to you for today, so this will be a 4. And then we're going to go ahead and fill in the blanks, and then we'll do a couple of examples. So with one of my colors, divide out prime numbers until you get down to 1. The GCF, stop when the prime number doesn't go into all the numbers. For number 3, the LCM, continue dividing until all the numbers are a 1. Number 4, multiply all the numbers above the line to find the GCF, or the greatest common factor. Multiply all the numbers to find the LCM. And this won't make any sense until we get started doing a couple of examples. Okay, so now we're going to do a couple of examples to help us understand these 5 steps that we have just gone through. So my first example, we're going to be using the numbers 8 and 12. And again, just like we did the other day with prime factorization, we're going to be doing the upside down division. And again, we have to use a prime number that goes into these numbers. So I'm going to list out my prime numbers just to help me remember. So we're looking for a prime number that goes into both of these. So I'm just going to start with the number 2. 2 goes into 8 and into 12. So there's my prime number. Go ahead and divide it out. 8 divided by 2 is 4. 12 divided by 2 is 6. So again, we still have to find a prime number that goes into both of these. And notice that 2 will go into both of them. So 4 divided by 2 is 2. 6 divided by 2 is 3. There is not another prime number that can go into 2 and to 3, so therefore I have to stop. And when I draw that line in the correct spot, when I draw that line, I'm going to then multiply those 2 numbers together, and that will give me the GCF. So 2 times 2 is 4. To find the LCM, we have to take these numbers and break them down till they get to the number 1. So again, we're using a prime number. Well, there's not a prime number that goes into both of them, so that I have to use 2. So 2 divided by 2 is 1. 2 cannot go into 3 evenly, so we'll bring that straight down. We have to get the 3 to a 1, so we have to divide one more time. And the only number that goes into 3 is 3. Because this is already a 1, we bring it straight down. 3 divided by 3 is 1. Now, to find the LCM, I personally like to circle them and notice that it makes an L, so I know that I'm doing the LCM. So I'm going to multiply all these numbers together. So we already have 2 times 2 we said was 4. 2 times 3 is 6. So 6 times 4 is 24. So my LCM is 24. So let me do another example. And I'm going to use 3 numbers this time. 11, 22, and 44. So again, we'll do the upside down division. Finding a prime number that goes into every single one of them when we're trying to find the greatest common factor. So a number that's going to go into all of them looks to be an 11. So 11 divided by 11 is 1. 22 divided by 11 is 2. 44 divided by 11 is 4. So we have to find another prime number that goes into all of them. And again, there is not 1 because of that. So then we have to draw a line. So our GCF is going to be the number 11. To find the LCM, we have to break these down to get to 1. So again, we do upside down division. Well, this is already a 1, so it's going to remain the same. So we're looking at these two numbers. A prime number that can go into both of them would be 2. So that's a 1. 2 goes into 2, 1. 2 goes into 4, twice. Again, we have to get this down to 1. So one more division. Prime number that can go into 2 would be 2. Again, these are already 1, so they come straight down. 2 divided by 2 is 1. So again, I'm going to make that L. Everything is down to 1, so I can multiply my L. So 11 times 2 is 22. Times 2 is 44. So my LCM is 44. Okay, so for our third example, we're going to be using the numbers 6, 10, and 25. Again, we're trying to find a prime number that goes into these three. And if you run through your list, you'll notice that there is not a prime number that goes into every single one of them. So if you look off to your notes where it says watch out, if nothing goes into all of the numbers, then the answer to GCF is 1. And that happens to fall into this case here. Because there is not a prime number that went to all three of them, 1 will be my GCF. Well, with 1 being my GCF, all the numbers, again, will be brought down. And we're going to find a prime number that goes into 2 of them, 1 of them. Either way, they all have to be broken down to 1. So it looks like I'm going to use the number 2. 6 divided by 2 is 3. 10 divided by 2 is 5. 2 cannot go into 25 evenly, so we bring it down. Again, we're breaking these down to 1. So I'm going to choose the prime number 5. 5 cannot go into 3. 5 goes into 1. 5 one time. 5 goes into 25. 5. These have to be brought down to 1, so I'm going to use the number 3. 3 goes into 3 once. That remains as a 1. 3 cannot go into 5 evenly, so we bring it down. And the only way to get to 5 is to a 1 is by using 5. And again, I'm going to multiply all these numbers together. 2 times 5 is 10. 3 times 5 is 15. Multiply them together, and your LCM would be 150. I'm going to give you 2 examples to do on your own. So example 4, you're going to be finding the LCM and the GCF of 25 and 30, or excuse me, 20 and 35. And then your example number 5, we will be using the numbers 6, 18, and 48. And again, you're going to be finding the LCM and GCF of both of these examples. If we want to go over to our notes again and to kind of finish out the bottom of our notes talking about our word problems. When it comes to word problems, there are keywords that you use to help you decide if the problem is a GCF or an LCM type of a problem. So when we're talking about GCF, is used when you're trying to group items, or again, if they're just looking for the greatest number, and that's where the GCF comes from. When you're talking about LCM word problems, you want to look for keywords that talk about meet up, at the same time. Anything to where they're meeting up or doing it at the same time would be LCM. So if we look at our 2 examples here, I'm going to read it out loud as you read it to yourself. There are 18 sixth graders and 24 7th graders attending a play. The teacher wants to have the same number of students in each row. If a row can contain only 6th graders or 7th graders, what is the greatest number of students that can be in each row? So when you go through this, you're looking for keywords that help you decide if the problem is an LCM or a GCF. And if you look right here, it says greatest number. So we know we're going to solve the problem using GCF. And you're not going to solve it, we're just wanting to know if it's GCF or LCM of 18 and 24. If you look in your second example, Rod helped his mom plant a vegetable garden. Rod planted two rows every 30 minutes, and his mom planted a row every 20 minutes. If they started together, how long will it be before they both finish a row at the same time? So you're looking for a keyword that might mean GCF or LCM. And right here it says at the same time. Well, at the same time means LCM. So this, we're going to solve this by doing LCM, and the numbers you would use would be 20 and 30. So solve these two examples for homework tonight, and we'll talk about word problems in class again.